Hello and welcome back to the Oxford MAT Livestream. My name's James and this is going to be a live stream about the 2024 MAT questions. Thanks for joining us if you're joining live or watching the replay on YouTube on the Oxford Mathematics Plus channel. I seem to be doing a sort of semi-scripted advert for the channel at the front. That's a bit strange idea, isn't it? Nice to see you. I haven't seen you for a few weeks since last time we met was before the test, and here we are several weeks later after a test. My plan is, well, I'll get there, but my plan is that I've only got a bit of time, sorry. We're going to look at the two long questions. The test this year, as you know, had 25 multiple choice questions and two long questions. We're going to go through some long questions today, so the two of them up there, 26 and 27, about vectors and talking ants. First though, I would like to know how your day is going in chat. And I have something to say about this, so we will see how this goes right in the middle. Okay, cool. And as always, if you want to join in with chat, we are live over at slido.com/MATLIVE, where it's being moderated by Callie, as always. Well, not quite as always, but Callie has done a fantastic job this term and last of moderating things. Yeah, what was going on in chat? Yes, okay, nice to see people again. Good to see people. People have noticed that, yeah, okay, right, good. Okay, my plan for this is to try and find people who, I don't want to call anyone out, but if it's the case that you were having a great day until you clicked on this YouTube video, because I saw some people in chat saying that they were stressed or they were really nervous about the test, my advice is to just not watch this. Just don't. Is this the only YouTube video where the guy at the front tells you not to watch it? But this is going to contain the questions, some discussion of the solutions, and also perhaps some discussion of things that are not solutions to the question. So if any of that would be upsetting to you, for example, seeing the questions again or hearing that something that maybe sounds a bit like what you might have done might not be as rigorous as you hoped it was, or something like that. If you don't want to hear that, then really don't want to watch it. You don't want to go through this. It's not worth it. It's in the past, right? And part of the reason I'm doing a shorter stream and not going through multiple choice questions is that I think the best thing for us is to try and say, no, maths already happened now. That was a couple of weeks ago, but it's happened. So I'm going to talk about the long questions because I think we can learn some things from them, but I'm not going to go through the multiple choice questions. I'm sorry, I guess, but also there are 25 of them. Good, okay, right. Somebody asks about the Twitch stream. Yeah, I haven't been doing Twitch streams either, partly because of the fear that a Twitch stream at the moment would turn into a MAT live stream, and partly because we've been marking the MAT, including at weekends. Good stuff. Right, okay, somebody asks how long it's going to be. I reckon it might be about an hour, but we will see. And sorry if you hear background noise. The building site's not too bad today, but there is a kind of protest march going on. So if you hear a protest march, then their protest is recorded and enshrined in this YouTube video as well. Yep, good, okay. Right, so other things that people are requesting in chat that we'll see are things like graphs and scores and all of the solutions, and I'm not doing any of that today. I've decided that some of the things that we used to do were just too stressful and not helpful to people in the middle of the admissions round. So there will be some statistics at the end of the admissions round, but today I just want to talk about these two maths questions. What's the funniest thing a person wrote? Do I do the funniest thing? There's some chance they're watching, right? The funniest thing I suppose was a long running thing that lots of people did, which was just fine. And I want to preface this by saying it's fine, which is quite a few people put a typo in the word ant. If you put the vowel U in there, then it spells aunt, which means like one of your parents' sisters. So we had lots of people suddenly talking about what aunts standing on the corners of a cube who would say yes or no to questions and always answer truthfully, which is quite nice when you're marking a few in a row and it's ants, 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 and then the next one is, oh, here are 8 of my aunts, and then ants again. That was quite nice. So I liked that a lot. Good. Do you know what? The protest has been going on for about half an hour and it's so echoey that I really am not sure what they're protesting about. I might go and find out after the stream. Good. Okay, so we haven't posted the questions or solutions or anything like that. This is in fact the first thing we're doing that has got questions in it. So here you are. Here are question 26 and 27. That's what we're doing. Right, good. Okay, I'm going to shunt the year off the screen that way and I'm going to shunt 27 off that way. I think we're going to zoom in and talk about 26. So last chance, if you don't want to, that hasn't quite gone, has it? If you don't want to see, there you go, over there, go over there. If you don't want to see question 26 about vectors, last chance, here we go. Right, let's lock that down as well. Okay, I'm going to put it here, I think, so that I've got a bit of chat on screen, and I've got chat there, question on screen, and some stuff up here. So, okay, question 26. I guess this is going to look a bit funny in hindsight, isn't it? But in this question, we're writing x comma y in brackets instead of the usual xy notation. You can imagine why that is, right? One of these things is way easier to type than the other. So technically in school, this is coordinates, isn't it? And this is column vectors, but whatever. We've written out our vectors horizontally so that we can type them. Yeah, okay. And we're going to multiply them. And then there's a bit that describes what's going to happen in the question. And we did this because in the actual test in 2024, candidates had this summary, actually the top bit as well. So the candidates had this stuff on the left during the whole question, and each part of the question appeared one at a time on the right with a box for them to type their answers. So that, a bit like looking at the top of the question, the kind of information that here is at the top of the page was on screen on the left. And the information here goes through the kind of structure of what's going to happen in the question. It's about vectors, where x and y are whole numbers, and whether or not they can be written in this form, where a and b are whole numbers, a and b and c are whole numbers, each greater than or equal to 0. So can you build it out of these things? Okay. Yeah, good. Personally advised to put the whole question on the left split window while doing the question. It's something helpful rather than flipping over. Yeah. So we could have done it so there was a page with the top text and then some other pages with the parts, but you'd have to keep flipping backwards and forwards to find out. This one doesn't have very much at the top, but flipping backwards and forwards. Split screen for this. Good. Okay, we're going to consider this set of S, and then we're going to consider vectors like this and find conditions that imply it can be written in that form. All right. Okay, let's do that. Mission of this question: which things can be written like this? We're going to find a condition that works like that. Okay, good. And James Bayliss in chat says the format worked well this year. Wasn't sure what to expect. Yeah, sorry. Obviously, in advance, people wanted to ask quite specific questions about what content was going to come up, which obviously we couldn't comment on because it wouldn't have been okay for me to say in advance of the mat, hey, people watching, vectors, right? So we had to not engage with a lot of questions about what the content was going to be like, but here you are, here are some vectors. You can do this with a normal keyboard. Okay, right, here we go. Yes, so partial credit is a thing for long questions. And when I don't have, sorry, Rob's cheeky mate, sorry we don't have math stats in this live stream, just maths. Okay, the stats in January. Right, okay, here we go then. Having said that, I've immediately scrolled it off the screen because in this PDF format or whatever, on screen, it's not working as well, is it? I should have it in split screen mode, shouldn't I? Maybe I should have built it like that. Anyway, classic live stream. Right, okay, so then the question starts proper. It says part 1. Consider the set S of vectors PQ with P between 0 and 4 inclusive and Q between 0 and 6 inclusive. P and Q are whole numbers, and how many vectors are in S? So a kind of observation that I think people in chat are playing along with. There we go. It's that there are 5 choices for P, and 7 choices for Q. These inequalities are weak inequalities, not strict inequalities, so they include 0 and 6, not 4. Count the choices. You can choose anything you like for P, and then after that you can choose anything you like for Q independently. So 35. Good. Is MAT digital now? Yeah, MAT was done online in Pearson VUE test centres this year in 2024. People saw the questions on screen and typed answers in a box. So there was this text box on screen where candidates could type 35, new line or something or whatever. Part B, explain why for any vector with x and y whole numbers we can find whole numbers a and b and a vector v in S. So this part's got quite a lot more writing in it, right? Such that and then these things add up. And the crucial part here is to notice that v is supposed to be in S, which is this reference back to this set S of vectors like this with kind of small components on there. So for any vector xy with x and y whole numbers, we can do this. Yeah, so there's no working out. People had kind of something to scribble on, but the questions you'll notice as we go through them are done in a way where you can type them in a box without having to type complicated mathematical expressions. Right, so people for this part wanted to tell us about, well, remainders is a good idea. And there's kind of two divisions to do here. There's the remainder when you divide x by 5, perhaps, and there's the remainder when you divide y by 7. And there's kind of a couple of ways you might get there. You might take components and realise that we want, if this is PQ, say, to make it look like the thing in the start of the question up here, we want 5a plus p to be x and 7b plus q to be y. There's a restriction on p and q, they've got to be small numbers. Okay, you should take the remainders when you do this division. And I'm multiple of s. What's s? Oh, the big S, like the set. Okay, I don't know. Will our MAT answers come up in interview? Probably not, because interviews... No, yeah, probably not, because in an interview you get to ask fresh things and see what people do with new questions. MAT is, I know, I'm going to say this again, I'm afraid, MAT is in the past. Good, okay. Yeah, so stats questions are still coming in chat, which is exciting. It's nice to know that kids these days interested in statistics. They're going to be released in January at the end of the round. Yeah, so people write remainders in different ways, by the way, and this was quite exciting trying to guess all of the ways that people would write out remainders. And some people use words, which is obviously fine, and some people have a variety of different notations that they wanted to use for remainders, which was fine. There were other approaches as well. So other people thought about this a bit more geometrically. To think about how increasing A is like a translation. So if A and B are 0, then you can make everything that's in S. And then increasing A by 1 is like a translation by 5 units. Increasing B is like a translation vertically. So you have maybe this kind of rectangle of points geometrically. Have I got a Desmos for this? I think I've got a Desmos. What's this? That's a Desmos. So you've got a rectangle of points down here somewhere, and then increasing A by 1 would give you another copy of this rectangle to the right somewhere. So you'd have this kind of rectangle where you translate it, and increasing B translates it up and tile the space. So you end up with points everywhere, filling everything. Good. Invitations to interview come out late November or early December. For maths and joint honours courses, including all the CS things as well. How do we show our working thinking process in interview if it's online? All interviews are online for Oxford. We tend to use online whiteboards when we can. Good. We've got a bonus episode about interviews in a couple of weeks' time. I'm going to come back in a couple of weeks, having recovered from all of the MAT stuff, and talk about interviews instead. So we're going to do more stuff about interview in a couple of weeks. On this channel. If you're subscribed, you will get this in your subscriptions as an upcoming live stream in a couple of weeks' time. Really plugging the channel for some reason. It's kind of exactly too late to plug the channel. Don't really know what I'm doing. Well, maybe some time travelers will like that. Yeah, so some colleges are using Miro. Most, so colleges who are doing online whiteboards are using Miro. Some colleges not using online whiteboards at all. Miro is the one that I'm using now. It's all right. You don't need to practice and get good at Miro or anything like that. I mean, you've seen me using Miro. Is this good? And we have lots of backup plans. Let's just try and reassure people as well. Obviously, we've put a lot of thought into it, and we've been doing interviews online for several years. Actually, longer than you think, because we've been doing online interviews for international candidates for ages. But anyway, here we go. Right, okay, so either geometrical translations or some sort of idea about remainders or some sort of idea that you can do some algebra over here maybe. Although if you do some algebra, you'll notice that you've got kind of 4 unknowns, A, B, P and Q on the board there. So it's not going to be quite as simple as solving things like that. Do I interview? Yes, I do. Good, okay. Okay, so if you're playing along to try and score points and keep track of your own score, then I'm not sure I recommend that. It's really hard to score your own work, especially if you're doing it from memory. But, I mean, I can't stop you. Here we go. Right, okay, for the rest of the question, we're going to call such a vector v the residue of xy, and we're going to assume it's uniquely defined. We give that fact here. Could have asked you to prove it, but I think if we asked you to prove it, the proof would be something like, oh, I just told you about remainders and remainders are unique. Or there'd be something like, or the line would be something like, I was thinking about it with translations and obviously these things don't overlap. So that's not part of the question, because if we asked you to prove it was unique, you would just tell us it's unique. Anyway, good. Okay. Why does everyone want to know if I do interviews? Yeah, hi. I do some teaching at New College at the moment, but I'm on 1-year contracts, so I can never guarantee that people, if you're applying at the moment, I can never guarantee that I'm there next year. I could be anywhere, haha. Are Oxford interviews from my tutors at college normally, usually with some help from other people, and it is normally quite college based. Good, right, okay. Are we moving on? We ready? We doing this? Yeah, we're going to try and get a live stream together here. Okay, next part of the question says, consider vectors like this: xy plus k times 2, 1, and xy plus m 2, 1, where k and m are whole numbers. Prove that if these vectors have the same residue, as defined in the previous part. I think I have back and forwards buttons if you want to go back to the previous part, but you just did the previous part, even though I've done a load of chat in the middle. We're going to prove that k minus m is a multiple of 35. Okay, and I think it's probably a good idea to write out what that means. So if they have the same residue, that means that xy plus k times 2, 1 is a50 plus b07 plus v. And I'm going to write out the same sort of thing for the other vector. But I'm going to use different letters because technically we know that their residues are the same, but we don't know that these bits are the same. If you think about remainders when you're doing division, then it might be the case that things have the same remainder, but they might not be the same number. And that's kind of what's going on here. There might be a multiple of 5 or a multiple of 7 on each component. Yeah, okay. I mean, you can go back. You can go back in the sense that you can see the previous part of the question. I know there was a system for switching whiteboard notepad stuff. And someone chat's just let us know they're learning Cauchy's residue theorem, which is excellent maths. Good. Not to do this question, I hope. Right, different maths. What was I doing? Oh yes, these things have got the same remainder, or same residue, I think we're calling it. So I think a sensible thing to do is to take the difference of these two equations, right? We have xy is in common in both. There's this v that's in common in both. So I think probably you want to do the difference of those. And the difference gives you k minus m, which is also in the question, so that's quite exciting. K minus m times 2, 1 is going to be something like a minus c 50 and b minus d 07. I'm using some factors about the way that the difference of two vectors works, and the way you can cancel and add vectors together fluently with the vectors, right? I like pencils myself, so yeah, people in chat telling me about pens and paper. It's on my list. And if you forget how you proved it, then that's probably for the best. It's in the past. Right, what am I doing? I've got something over here that's a multiple of 5. I've got something over here that's a multiple of 7. It feels like I'm done. I should probably write out why I'm done. Actually, there's maybe a sentence here, I suppose, that if I take components of this thing, so take components, I found out that, well, we've always known this from previous MAT exams, but nobody likes writing sentences. I know that from my current undergrads as well. Hi, if any of them are watching along in chat. Write sentences, or at least some words. Nobody likes writing sentences. Look, I'm writing on the board and I'm not using sentences either. So then you might point at things here and say, look, a multiple of 7. Behold, this must be a multiple of 7 as well. And technically you should do this a little bit. I mean, technically there's something subtle going on here to do with prime numbers, but not part of the marking criteria to look at your understanding of prime numbers right now. I think what I'm expecting is that k minus m is a multiple of 5. Because look, here's a 5 over here. So this side must be a multiple of 5, and it's not going to come from this 2, it's going to come from k minus m, and a multiple of 7. Good chance that someone is currently typing. It was not fair. James just underlined the word and. Yeah. So this says 4 marks on screen in big bold letters or something. There is partial marking. So people could get partial credit for having part of the ideas here, or by proving this but not in an extremely convincing manner or something. So we could do partial credit for people who did some of this. Maybe if you assumed that A and C were the same and assumed that B and D were the same. Well, actually, that doesn't really help very much, does it? Because when you do the difference, you're going to get 0 on the right-hand side, which is going to tell you something very strange about K and M. So maybe not much partial credit there. If you concluded that K and M are both 0 or something, then I don't know. If you think that K minus M is exactly 0, then I'm not sure how many marks you get for that, but yes. Good. And yeah, so some people are keen on remainders, keen on modular arithmetic. The question's written so that if you know about modular arithmetic, then what you're actually writing is just remainder, essentially, every time. Because if you don't know about modular arithmetic, you don't miss out. You've seen the concept of remainders, I hope. If not, you invented it in part B of the previous part. You can keep saying that again. And actually here, hardly doing anything to do with the remainders at all, because they've cancelled. Good, okay. Oh, I didn't do my punchline over there, did I? But you knew where I was going. If you're a multiple of 5 and a multiple of 7, then it must be a multiple of 35. Which is the thing going on in here. For part B, can you use the contrapositive of the statement of part A? Yeah, I suppose so. I think that's where we're going. Occasionally parts A and B are together because they go together. These ones are more sort of separate, aren't they? Just 2 tasks to do. Here they're together because they go together. So here we're supposed to prove that they all have different residues. So the strategy suggested by Anonymous in chat is to say, aha, if same, then by part A, the numbers, which, okay, here there's a minus sign, but those are still numbers. K and M are whole numbers, right? You could look at the difference between those. Then by A, difference is supposed to be a multiple of 35. Now, that's not very clear, is it? I can do maybe better if I gave these things names. If I wrote this out in a sort of proper, like, well, suppose that 2 of these have the same residue, then, call them xy plus km, xy plus k thing, and xy plus m thing, where k and m are numbers between 0 and minus 34, the difference is supposed to be a multiple of 35, but if you pick numbers from 0 to 34 only differ by at most 34. And if you're feeling really fancy, you say, well, no, you don't write underneath the chat. If you're feeling really fancy, you say, they could differ by 0, of course, but then they would be the same vectors. So technically the proof, I suppose, is if they have the same residue, then they are the same element of this set, but hey, whatever. What was my favourite place within Oxford? Oh, there's this place, it's called Mission Burrito. They have a really good loyalty card and they sell burritos. It's pretty good. And kind of Mexican soda, which is good stuff. Was that an acceptable answer to that question? Yeah, probably. Ooh, does A minus C have to be a multiple of 2? I think it does actually, yes. Quite a good point. There's a 2 on the left, you can read left and right. Is that over here somewhere? Well, ages ago, sorry, but there's an AC on the right and there's a multiple of 2 on the left. It looks like A minus C is even to me. Is that important? Not for that part of the question, I think, but true. I think. Right, good, okay. So far, not exactly obvious what we're doing. There was that summary at the top of the question, wasn't there? By considering the vectors like this, we will find conditions on X and Y that imply it can be written in that format. Okay, great, can't wait for that to happen. Here's part 3. Time check, doing okay. I liked this paper more than previous papers, but that's me. I like every paper more than the previous papers. Is that true? Yeah, that's pretty much true. Always improving. Okay, part 3 says hence. Hence means using the previous part. Hence show that if x is at least 68 and y is at least 34, with x and y whole numbers, then the vector xy can be written in this format, the golden point of the question, that we can write it in this format, where a, b and c are whole numbers each greater than or equal to 0. You don't need to actually solve for a and b and c. Of course, that'd be awful. You'd have to do it in terms of x and y or something. It would be a mess. So I think I'm going to get chat involved. 23 was nice. I think maybe we peaked in 23. 23 had the square number question, which first years have stopped me around department to tell me they didn't like the square number question. So it could be worse. Could have had to do the square number question. Right, there's Ant1. Hello, Ant1. We'll get to you in a second. What are we doing? Right, yes, we're going to think, what's the link between, we've got these things in here we were just talking about, where we had xy minus 2, 1, minus 2 times 2, 1, minus ... minus 34 times 2, 1. And we like to say, if x and y are both large numbers, large enough, then we can write it in this format. What we've just proved is that all of these things have different residues. Anyone in chat want to join in with that? There's some lag for chat, so I get to drink some tea while chat is getting back to me. The problem is that you finished typing and it hasn't appeared yet. No, you're just watching me drink tea. Quite a lot of people spotted that 68 is twice as large as 34, and that the number 34 was just in the question. And that is relevant. That this bit over here, there's such a mess on screen, isn't it? It's a good thing we switched from, this is what I'm like when you give me a bit of paper, I just write all over the top of it. That this vector over here, look, is 34 times 2, 1 would be 68, 34. Right, it's being subtracted over here. We're going to make sure that x is at least that big. Yeah. So sub 68 and 34, what does that mean? Back to part A. Ooh. Back to part A. Someone else agrees. What's going on? Use part 1. Everyone uses part 1. What happened to part 1? Oh, so in part 1, you know there are 35 vectors in S. Good call, chat. I like it. 35 vectors in S, and here we've got a list of 35 different residues, each of which is in S. So we have 35 different residues, and one of those will be well, they're all different. There are only 35 things in S. So as S has 35 vectors, one of these is 0, 0. And you might do that in 2 steps. You might say, we've got everything. This is a full collection of everything from part 1. This is as many as you can have from S. I'm good. The next step then is to say, which one do you want? Well, I would say 0, 0 is the important one. That's something that's in S. And if you have 0, 0, then it makes the rearranging nicer. So that means that there exists, let's say K, such that, I'm underneath the chat, aren't I? Such that xy minus k21 has residue 0, 0. And now we're essentially done. If we write out what the residue 0, 0 means, it means that that this thing, it would mean that it's A, oh, which way around is it? 5, 0? Yeah, 5, 0 plus B, 0, 7 plus 0, 0, which is why I care about 0, 0, right? Plus 0, 0 for some A and B. It's this for some A and B. And then just move the K21 on the right hand side, and that's exactly the format that we wanted. The 0, 0 vanishes because it's 0. Ah, subbing in 64, 68 and 34. Ah, right, I see what you're doing. So if you sub in 68 and 34, you'll find out that this last vector, there it is still on the screen, this last vector is 0, which is your clue that the necessary thing here is that we want all of these vectors, what do we want? We want all of these to be positive numbers, don't we? So that we know that, yes, that we know that A and B are positive. Because we've got this thing in here. Yeah, so last conclusion then, I suppose, since xy minus k21 has positive or 0 components, because you subbed in 68 and 34 to find out how big those vectors were. The smallest the numbers could be is if we subtracted 34 times 2, 1. Since this is true, A and B both positive or 0. Which is, I guess, what we want. We want A and B to be positive or 0 numbers, and we want C to be this thing that's somewhere between, well, 0 to 34. So actually you've proved something a bit stronger. You've proved that these vectors, once x and y are large enough, can be written in this format, and that C doesn't need to be larger than 34. It's not too bad, is it? Not too bad. There's the aren't typo. Oh. Yeah. C is going to be positive. We're fine because we're subtracting K, and then we're going to add it to the other side. I haven't moved it over to the right hand side, but you know, once I've moved it over, we'll be all right. Good. Okay. And then that's the chunky part of the question, to prove that when the numbers are big enough, you can write it in this format. I'm not going to find A, B, and C. This is kind of a non-constructive proof, by the way. I sort of almost the pigeonhole principle, but not quite the pigeonhole principle. If you know what that is, don't worry about it. If you don't know what that is, I've just said it's not quite that. You're proving that something happens eventually or somewhere. That if you throw 35 darts at this darts board and you know that all of them hit different squares, and you know that there are 35 squares, then all of them hit the bullseye. So don't know which one. I'm rubbish, but. And they all hit different squares, and there's only so many squares to hit, so we got there in the end. Good. If you have any contextual criteria, are you more likely to get an interview? Let me try and rephrase what's on the website. We look at applications in context. We get some extra information from your application. Your teacher's reference has a section adding any extra context that we might need to know about your educational or personal circumstances. We also get extra stuff from a couple of other sources. Get some statistics if you care from about school performance and things like that. We look at that rather than just taking the people who, rather than just taking the N people with the highest GCSE scores or something. We look at that information as well. That's not the way to say it. I learned about pigeonhole principle. This one's not quite, because we've got the same number of pigeons as pigeonholes. One day I'll explain pigeonhole principle. Might have done that already, can't remember. Right, last part. Student makes this claim. The student's claim is not correct. The student's claim is not even close to being correct. I'm afraid. There are loads of examples where if you make x small or y small and mess around a bit, then you will discover some failings. I have a diagram for this. So one example might be, what do I need to do? So positive. So maybe 103, I think, can't be made. Because how are you going to make that 1? You know, it's ridiculous. If you set this to 0, then you don't get anything. If you set it to even 1, then it's too large. If you set this one to 1, then it's too large. So you can't make this one. Yeah, 101 is in chat. Yeah, as they say, x plus y at least 102, so that's okay. Good. Okay. There is a diagram for this. If you said yes, I can't remember what you get for saying yes. I can't remember. Sorry. Here is a diagram. So this is not showing up well on screen, is it? But this is small dot if it can't be written in that format, big dot if it can be written in that format. So you see this diagram, it's a bit of a mess, isn't it? So there's multiples of 5 along this axis, there's multiples of 7 along this axis, and then the 2, 1 vector fills in the gaps in the grid that you would get. So without the 2, 1 vector, you can only make things on this kind of 5 by 7 grid, but then the 2, 1 vector adds on. It takes this 0 and runs with it to say, I could add on some 2 1s in there, running off in that direction. So you get this kind of lattice of points that then off in that direction. And the observation when you see this picture, depending on the resolution it is appearing on your screen, is, oh, there's a huge rectangle. Right? I don't know if you can see the same rectangle as me, but there's this huge rectangle. This huge rectangle that's all points that you can make. And that's what you've proved in this question, that you can make this rectangle. Which one have you proved? 68, 34. You haven't quite included all of this stuff, but there's this big rectangle where you can make everything, which you did. And outside that, it's a mess. So the student claims, I've got the line, but I'll draw it again. The student claims that you can make anything above that diagonal line. I don't know if it's displaying on your screen, so I'm going to draw it a little bit here. Let's draw that line. There you go, that's good enough. The student's claim is that you can just make anything above this line, as if you can make everything except a triangle. And that's not true, because I've committed to doing this in my right now. There's all sorts of gaps, right? Around here and around here especially. So if you make x small, or if you make y small, then you can find some gaps, especially near the axes, which is why people are saying like 1,102 in their bits. I'm really sorry in chat if you've said the student was correct. I'm so sorry. I can see why you might think that, because the student has taken 102, which is the sum of 68 and 34. Their triangle, their kind of region includes all of the stuff in the rectangle, but it also includes some other spurious stuff that you can't make. Yeah, there you go. Yeah, that's at the top of chat there. If you say x is 1 and y is 101 and prove that it didn't work, you have disproved the student by looking over here, and that's fine. Yeah, one counterexample will do. You don't need to have any idea about the graph of what's going on. Oh, I tried to make this in Desmos. I will demonstrate in Desmos just because I went to the effort of making this. So if you take the 25, if you take some points in that 2, 1 direction, going off in that direction, and then you start adding on 5s and 7s in each direction, then you kind of make this shape that looks like the shadow of a big cuboid almost, and it ends up being filled in the middle. And the larger you make n, the larger this filled in region is. So that if there's no limit on how many 5s and 7s you can use, then you get back this large filled in rectangle of points that you can make. Desmos is not very happy about sketching this many points at once, so I've had to do some funny business on the left. Right, that took ages to work out how to do, so I'm going to have to show you my Desmos. Right, okay, good. That's 26, I think. Long question is 15 marks in total. You are not trying to score your attempt, you are trying to get closure on that whole vectory stuff kind of situation. Good, okay. I'm sorry if you thought the student was correct at the end. That is only a few marks at the end. Good, okay. You want that as your logo? I'll put the Desmos in chat. Hang on, I'm very proud of my Desmos. How do I put Desmos in chat? Chat, how do I chat? Okay, I'm doing it. This is the halfway time break. Remember to look away from the screen, remember to blink. Oh goodness me, talking too much. There we go. Okay, let's see if Callie approves that, or maybe it looks like a random link. Okay, let's talk about cubes. Hey, got approved. Hooray! Thanks, Callie. Okay, 27. We're going to go a little bit faster on this one, I think. So here's a cube. A little bit surprised this diagram of a cube's made it in, although I learned that some people really aren't sure how many corners a cube's got, so maybe the picture of a cube was helpful. It was on screen on the left while you were doing the question, I guess. And the faces are painted either blue or red. There are ants on the corners, or aunts if you like. Your aunts are on the corners. One person said, standing proudly on the corners. What did they say? They had some really nice way of putting it, like how important the ants were for standing on the corners, which was nice. Not in a Marx kind of way before everybody thinks, but the key to this question was to show deference to ants. That would just be weird. Right, I'm having a weird halfway break. Am I ready to go again? Yeah, sorry about the cube. You're not going to like the diagram I've got underneath. Callie will be approving links posted by username James Monroe. Callie is now going to find out that usernames are not unique or verified in any way. Right, good. Okay, so there's quite a lot of possibilities for how the cube might be painted. Each face is either red or blue. In fact, there are, I think, 10 cases, and that's work. So some people went through and checked 10 cases to do with, there might be one blue face or none or 3, but if there are 3, there's a couple of possibilities. That's work. I'm going to try and do this question without going through all the cases. So if you went through cases, then that's valid. And depending on how you did that, and did you find 10 cases, then you can get marks. But because that's quite a lot of stuff to write, I'm going to try and show you how you can do questions without doing all 10 cases for how the cube is painted, without having to think about that. I've tried colouring in one face so that it hurts your eyes less. I don't know if that helps. We'll get there. Okay, so the ants are each asked, can you see an even number of red faces? Each ant answers either yes or no. Explain why the number of ants that say yes is itself even. What I like to do for this question, I think, and there are several things that work. Somebody is pretending to be in. No, you're not. To be clear, if you did all the cases, you're not cooked. It's just that's not what I'm going to do on the live stream. It's fine. My Marcus had to read lots and lots of case-based approaches. That's fine. I just want to do something different. Okay. I'm not going to read out. It could be 3 red faces at a corner or something. Okay. So I like to think about this one as the total number of let's go red. Yes, red faces seen by ants, because this is, on the one hand, you could go through and say well, look at each of the ants and ask them how many they see. It's 0 times the number who say 0, number who see 0. It is +1 times the ones who see who see 1 plus, 2 times the ones that see 2, the number who see 2, plus maybe 3 times those lucky ants who see as many as 3 red faces, which we can work on. But on the other hand, it's also just 4 times the number of red faces, because each face is seen by 4 ants. So this is kind of total thing, which makes sense. I hope that the more red faces you have, the more you're going to tend to have ants that see 2 or 3 or 1 red face compared to ants that don't see any. And you can track that through all the cases, but this is kind of total quantity, where if you multiply the number of red faces by 4, then whatever it is, you're going to get the total number of reports that you get from the ants, if you like. Okay, yeah, didn't write it mathematically, but explained it logically. That is the point of this. I have written it in the format of an equation because, well, it's not even a very good equation, is it? It's got loads of words in it, but sentences acceptable, encouraged even. And you plan on reviewing the, yeah, good. If you are not enjoying the live stream, please do not watch it. I am going to talk about the rest of this question. I'm sorry. I don't particularly want to. And if I were in your position after doing a test, I would be trying to move on. Gosh, would I be watching my own content? Maybe not. Oh, it's food for thought, isn't it? Anyway, what am I saying? This thing's even because it's 4 times the number of red faces. And on the right-hand side, well, I can see lots of even things. Importantly, I'm going to end up with saying this is even because it's, it's 0, isn't it? This is even, so it's 0. This is even because it's multiplied by 2. So I'm left with the number who see 1 and 3 times the number who see 3 added together is even. That means that the number who see an odd number of red faces must be even. Because you can, because they're included in these counts, and however it's split, you're going to end up with an even number. I've said that terribly. Gosh, I wouldn't have given that marks if I'd written that to myself. What am I doing? I've got lost. Right, cool. The number who see an odd number of red faces has to be even so that the total works out. And because there are 8 of them overall, that means that the number who see an even number of red faces must also be even. Goodness me, what a convoluted way of arguing. Didn't write numbers. Yeah, what did you write? Yeah, okay. So there's arguments like this where you think about the total of what's going on overall. This is how I would do the question. I'm not doing a good job of explaining it, am I? And it's also not what lots of people did. Yeah, 4 ants see every face. Yeah. Cool. And so people instead talked about, some people talked about a kind of progressive building sort of approach, where you start with everything blue and then you paint things red, and every time you paint a face red, something switches, 4 things switch. And it's a little bit tricky because, well, some of those ants might have been saying yes, some of them might have been saying no beforehand, but 4 things switch. You can make that work if you imagine the cube starting blue and painting it gradually red, or vice versa. Some people had an argument where you try to pair up the ants, and there's something quite awkward about trying to pair up the ants, which is that your pairing needs to work in all cases. And there's this one awkward case. I'll just show you this diagram, sorry. So if the cube's like this, with 3 blue faces together and 3 red faces together, then I've marked with green dots here the ants which can see an even number of red faces. And the sort of awkward thing is that there are 4 of them. It is even. This case works. This case works, but it's quite hard to explain how they're paired up. They're not paired along edges, and they're kind of paired along faces, but then you have to decide which faces you're using, and they're kind of paired across diagonals or something. So it's kind of awkward to explain how they're paired up, if that makes sense, in this particular case. So again, if you're doing all 10 cases, then this was just one of them, right? You think of this case, you check that there are 4, and then you move on to your next case. But if you're trying to do a kind of clever argument where you pair up the ants to say, aha, it's even because they're in pairs, then it's not the case that you just like read along the edge and find a second ant over there. Because look, this one sees an even number, but it's not connected to any others that see an even number. The other cases work in a slightly different way. So it's sort of awkward that you want to say, maybe you want to say it's even because they're in pairs, but it's not obvious how you're going to pair them up. Good, right. Okay, yeah, so some sort of switching and parity stuff seems quite popular. That's a little bit like induction, if you've seen that. Right, okay. So that's quite a tough intro to a question, I think. You can maybe approach it by thinking about cases or building things up slowly. We've always talked about starting with small examples and building your way up. So think about maybe not having many red faces and what happens as you paint red faces. Is it possible? Is it possible that all 8 of the faces can each see exactly 2 red faces? And I think the answer to this is yes. I think you can just do this. So that's consistent with the previous part, but we should check that you can actually do it. And one solution is to paint the top face blue, bottom face blue, or your favourite pair of opposite faces blue. And then if you do the rest red, then there'll be this kind of ring of red faces, and every ant will see 2 red faces. Unsure how you expected us to answer the cube question in the time limit we were given, without being able to make a cube like you did online. To be clear, the cube that I made online took me ages to build, and I wasn't expecting anyone to build a cube in the test. I think I was expecting you to imagine colouring in the faces, and imagining it is way faster than building it online. Sorry about timings, I suppose. Again, what was thinking QED? Yeah, I wasn't expecting to be, obviously not expected to draw a cube. I think we had a couple of attempts at drawing an ASCII cube, but most people opted to describe this with words, to say which faces they were going to paint blue and red, to describe it with words for how they're going to do it. In the text box, you can type sentences about how you're going to do it. Oh, there's one person in chat, drew a map of the cube and was trying to explain it. Yeah, people. I know it's recent in the test, but you know you're anonymous. This is fine. People go to great lengths not to use words and sentences, just like my current undergraduates. If any of them are watching, they can maybe sympathise with the idea of drawing an ASCII cube rather than using the word top face. Oh well, okay. Right, how are we doing? How to draw by typing? Don't do that. Yeah, I don't think you need to. No, I'm going to erase this. I'm trying to draw it on the screen so that I can show you what I'm imagining. But that works just fine. That's a description. Top and bottom blue, rest red. Yes, I justify. Maybe I'd say, maybe I'd type a sentence just for fun, but I think that's good enough. Do not draw this by typing. I mean, it's in the past. The face of the cube is all due to perspective, isn't it? I attempted to draw a cube online, but it took me half an hour. Why? Okay, we're not doing any statistics today. Sorry, if you come for stats, it's not your live stream. That was weirdly hostile. Sorry about that. Okay, right, here we go. The answer asked a different question. Can you see at least 1 red face? So previously it was even number, and then exactly 2, and now it's at least 1 red face, which is different. Some people did switch around red and blue during the question. We tried to follow what you were doing, and we tried to be nice and give marks where we understood what was going on. We're going to explain why it's impossible for exactly 5 of the ants to say yes, and exactly 3 to say no. So people did quite well at this part, spotting that, well, if 5 of them say yes, then they can see So they can see at least a red face. So there must be a red face. And then once you've got a red face, 4 ants can see it. If 4 ants can see a red face, well, we're almost there, aren't we? We want 5 of the ants to see a red face. We've got 4. But we're going to need at least 1 more. And to do that, we're going to have to add at least 1 more red face. And if we add it adjacent or opposite, we get too many ants saying yes. Either 6 or 8 would say yes. And adding more red faces doesn't fix things, it just keeps going up. Although it goes up in a confusing way because it can sometimes be 7. The example that I showed you in the kind of rotating cube thing there for a second ago, I think 7 of them can see it, at least 1 red face. So it goes up in a weird way, but it goes up. The more red faces you put on, the more ants can see 1 red face, or it stays the same. Right, good. Okay. Then 5 is greater than 4, so more. And people manage to chase that through and say, well, if you put another red face on, then things have gone badly wrong. So some people try to take a shortcut by saying 5 is an odd number, and that's not enough because it could be 7. 7 can happen. Do examiners purposefully subtract marks for unclear answers? No. Examiners purposefully award marks for clear answers. Everyone starts at 0, and then if you say a clear justification, so in this instruction here where it says justify your answer, if you do that, then you get marks. If you don't do that, then you don't get marks, but you started with nothing anyway, so good. Okay. I did the MAT hungover. I think I'll have around 60-65% thoughts on interview chance. Okay, well, we're learning. Suppose that the ants on the corners of the top face of the cube can each see exactly 0, 1, 1 and 2 red faces each in some order. How many blue faces might there be? And it says find all possibilities. And the reason there are possibilities, which maybe people spotted, is that these ants are all around the top face. So the bottom face could be red or blue. These ants can't see it, so that wouldn't change anything about their numbers. So there are 2 possibilities, and in fact it is exactly 2 possibilities because this is enough information to work out where the red faces are, except for the bottom face. This one can see 0. That one's quite a big clue because if it can see 0 red faces, it means that the top face itself is blue, and also 2 of the side faces that ant is looking at. But then there's one that says 2, and it's not looking at the top face as a red face, it must see 2 of the side faces as being red faces. So then overall, I guess you've got 3 blue faces from here, plus maybe a 4th, and the others have to be red so that you get this. So you get this 2. A little bit like Minesweeper. So how are we supposed to explain that much with the time given? I'm talking maybe more than any candidate talked about these questions. I'm trying to say it lots of different ways. Good. Okay. Good. I'll set that time. Taking approximately 1 hour to answer the 2 long questions. I do also have to talk to chat though, don't I? And I already knew the answer, and I'm doing it twice. Yeah, it still crossed about time limits. Okay. I already apologised. Good, okay. Part 5 then. I think there might be 3 or 4 blue faces for part 4. In part 5, 3-dimensional shape is constructed such that each face is either a square or a hexagon, with 2 faces meeting at each edge and 3 faces meeting in each corner. And each face of the shape is painted either red or blue. Consider the edges where a red face meets a blue face. Explain why the number of such edges is even. This part, I think, might have been too hard, in the sense that I would like it if people made progress through the last part of the question. I don't think many people made progress through this part of the question, so I think it might have been too hard for with my hat on of someone who wants people to get all the way through the questions, too hard. I think fine as an admissions question, which is, let's not forget what it is, but maybe a bit of a shame that we didn't get more people getting through this part of the question. There it is though. We've got to explain why the number of edges where red meets blue is even. And this is pretty similar to the first part of the question in a way. Well, proving why something is even is something we did way back up in part 1 at the top of the screen there. So yeah, so you could do something where you build up again. If you did something like that for the first part where you imagine it starting blue, there it is in Jan, starting blue, and then each time you paint something red, keeping track of what changes. And in general, it's quite tricky because the thing that you're painting red might be a square or a hexagon, and it might have been touching several other faces which were already painted blue or red. So the thing that you're painting, when you paint a face red, if it was previously blue and adjacent or next to, I don't know, B blue faces and R red faces, then it had, how many did it have? Previously it was blue and it was adjacent to R red faces, so previously had R such edges where red meets blue, and now has, well, what does it now have? Something like, now has, oh, it's now red, so it now has B such edges because it's now red. A change of B plus B and minus R. We lost R of these things and we gained B. We would like to explain why that's an even number, because the thing starts with, maybe it starts all blue and we're painting the faces red. So this change of B minus R, it's not obvious why that's even, because these could have been anything, right? Except, aha, B plus R is 4 or 6. It's even because this thing is either a square or a hexagon. So there's B and R, maybe you might have called them something different using the fact they add up to 4 or 6. So B plus R minus 2R, this thing that we've got, is even 2, because it's B plus R minus twice R. So that's even 2. So the change is even, so it starts even and the change is even. There's a more whimsical approach. Which I think actually nobody wrote. But a more whimsical approach works like this. Put a beetle on each edge. If you put a beetle on each edge, then you can ask the beetles how many red faces they see. And the beetles might see 0 red faces if it's blue-blue, they might see 1 if it's blue-red, or they might see 2 if it's red-red. And you could do something just like in part 1, thinking about the total of red faces seen by beetles. On the one hand, that's going to be something even, because any shape that's painted red is seen by an even number of beetles each. On the other hand, the total of red faces is twice the red face beetles, an even quantity, plus the red-blue beetle, the beetles that see red-blue, counted singly. So we've got, again, an even total quantity that's made up of some even parts, beetles that can see 2 red faces, and some other part that we're interested in, beetles that can see 1 red face and 1 blue face. And this time there's no sort of prefactors of 3 or anything to worry about. It's just interesting beetles plus an even number is an even total. And that means that the number of beetles is even. You can see red, blue. Would it have to be a beetle to get a mark? No, of course not. And actually, I think nobody talked about beetles. I put beetles in one of the example answers to give to the markers so that they knew what sort of things to look out for. But obviously, why would you pick beetles? That's a sort of whimsical way to do this last part. You have phobia on ants, so you cannot answer this question. Good news, you are allowed to switch them out in your answer, so that if you read this question as ants, then that was fine with us. I was a bit surprised by how many people spelt red wrong, even because red's in the question. People still spelt red wrong, and it's, oh well, never mind. Marked that as well, so that's all right. Would you like to see the shape? I mean, there's lots of things it could be, and some people told me that what they thought it might be. In my head, the shape is a truncated octahedron. It's one of these. Sorry for the people with issues with looking at nets, looking at projections of 3D shapes. I'll colour in the front face. A cube octahedron is made of squares and hexagons and has 3 things meeting in each corner. Oh, what am I doing? I've coloured in that one, so yeah, I want to colour in this one next. There we go, that's nice. And then this one. And the squares and hexagons meet in various places to give this kind of shape with different bits and pieces. It doesn't have to be one of these. It might be a cube or a hexagonal prism and possibly something else, but lots of possibilities about what the shape might be, which is why that's in the thumbnail. Good. Okay. I used sides and faces interchangeably and had to scramble to fix it. Yeah, the sides is all right. If you use faces and edges interchangeably, then things get very confusing. And if you use edges and vertices, or edges and corners interchangeably, then that's very confusing. Some people use sides and faces as slightly different things. Like the face is a hexagon and that has 6 sides, and then 2 sides make an edge. And that sort of technology might be handy. Did I write this question? I wrote some of this question. Was a football involved? No, it's a pretty bad football, isn't it? It doesn't have very many faces. Footballs have pentagons on as well, don't they? I've seen a football. You can't get me with these sports questions. I can do this. Interview offers come out end of November or early December for maths and CS candidates. It's worse colouring it in. Sorry, people are not enjoying that picture of a shape. Okay, some people are really not happy about the cube. What could I have done with the cube? I guess I could have coloured in some of the faces. It still doesn't feel like it's helping people's vision that much. I could have put dotty lines for the ones at the back. Maybe that's nicer. Standard way of showing something's in the background, right? Dash that out. That sort of worked. Not amazing. Maybe that helps you pop it one way or the other. Good. Okay. Right. Other approaches are available for this last part as well. So there's the Beatles on each edge approach, which is my pet favourite, but not a popular method for doing the question. There's some sort of tracking what happens as you paint the faces, and there's some arguments about looking at the vertices and doing things from vertex-based places, which is fiddly to get right. There's lots of approaches for what you might do, and it's quite hard. For logic that's flawed in some cases, like paired ants, working marks still available. Really depends. Depends on what you wrote. Think about getting actual humans to mark it rather than just, I don't know, feeding it into a computer or something. We looked at each thing that people wrote. If your pairing was sort of close to working, then good. If it doesn't work, then no. Why don't people get sent map marks as soon as all the marking has been finished? Honest answer is that we don't want to put you off from interview stuff. But we would like it if you did interviews without knowing your mat score. We worry a little bit that if people know their mat scores, then they might try and use that. They might try and it might make people approach interviews weirdly. Good. Okay. Right. We're not doing stats for the rest of the hour, I'm afraid. We're going to cut this one a little bit short, I'm afraid. Right. With the first long questions, is using modules correct? Do you mean modular arithmetic? If you mean modular arithmetic, which is remainders, then yeah, you can do some of that. If you mean groups, rings, and modules, the algebra structure, then no, sorry. Right, good, okay. Oh, I forgot to tell you that this question is about chicken nuggets a little bit. Do you know the chicken nugget problem? It doesn't really help if you know it or not, but there's this classic number file video about chicken nuggets. Chicken nuggets come in boxes of 4 or 9 or 20. And there are some numbers that you can make using these, like 33 is 4 plus 9 plus 20, and some other numbers that you can make, like let's do 17. 17, if you want 17 nuggets, you can get 2 4s and a 9. And there are some numbers that you can't make, like just a single nugget, or exactly 7 nuggets. This question is the chicken nuggets problem, but with vectors instead of nuggets. So I guess the vectors are the size of the boxes of nuggets. This is also the postage stamp problem. But the postage stamp problem and the chicken nugget problem are in 1D, and this question is in 2D. It's in higher dimensions than the chicken nugget postage stamp question. So even if you'd seen one of these problems before, it's unlikely that that helps you at all, really, because A, 1D is quite different. B, the question is sort of on rails. It tells you how to make progress with the question, to do this and that, and then hence do this. So if you've seen an argument about 1D chicken nuggets, and I don't think that's in the number file video, but if you've seen the 1D nugget argument, then I don't think that helps you very much. What we're trying to prove that there's some huge number that you can make. Right, okay, I don't think you have seen anything crumple. Somebody has just jumped into chat and divided by 0 a lot. Oh dear, that's not allowed. That's really not okay. We're going to have to call it there in a minute, I think. I'm not doing, because I'm not going to do stats or multiple choice questions. Sorry. Can I tell you anything interesting about ants before we wrap up? Anything interesting about ants? Oh, so the ants, and again, this is not really helpful, but the ants are almost doing a sort of minesweeper thing, if you've ever played that game with the mines. I mean, not really. 80% of the question, obviously nothing to do with minesweeper. It's just when I'm doing the 0 1 1 2 thing, that part 4, it reminds me a tiny bit of Minesweeper, where you get the numbers and you have to work out what's going on nearby. But even if you've seen Minesweeper and played Minesweeper a lot, then I don't think that helps you very much with the question. Right, good. Okay. Can you put Alice and Bob in next year? Alice and Bob, classics of the genre. Why are the ants not named? Alice, Bob, Charlie, etc. We'd have had to name 5 more of them afterwards. We'd have to come up with more names. And then the names wouldn't really be relevant, but maybe it would. Oh, maybe people would tell me, like, Alice is lying. What if the ants are lying? At the moment, they answer truthfully. And you could do a version of this question where the answer's sometimes lying, and that sounds really hard. Good. Does the 4-color theorem hold in 3D? Depends what you mean. So in 3D, if you're on the surface of the Earth, then yep, that's the one that the 4-color theorem is for. If you're on the surface of a donut, then the answer is actually 7. You need a 7-color theorem. There are maps that you can't 4-color, or indeed 6-color. You need 7. And there is a general rule about what happens if you have a double donut. Can you draw a really weird map that needs loads of colours? The answer is yes. So more stuff. Good. The ants do not lie. There you go. The ants don't lie. They can't. Why would they do that? Yep, somebody asked about 4-color map theorem. I'm not sure why. Someone asked if it holds in 3D. That's the point of it, right? Is it? I mean, it holds on. The thing is, if it 2D and the surface of a sphere, so I'm being a bit silly really, but the surface of a sphere and 2D are pretty similar for the purpose of maps. All you need to do is choose one country. You've got your countries on the map. Choose one country, stick a pin in it, pop the surface of the world open at that point and unroll it, so that now you have a 2D map with one extremely large country around the edges. So if you can do 2D plane, then you can do the surface of the Earth by sort of taking the Earth, flattening it out and colouring things in. The interesting thing is that on the donut surface, if you pop it, then it's still not flat. Topology, right? Any other interesting misspellings or typos this year? To be honest, it sort of blurs together a little bit. Everyone's vectors and aunts. Which are the aunts? I think we're good. I think we might have got there. Ants don't talk, so the question is not valid. Absolutely, yeah. Can't be having that. None of the ants ever say that they can't see even and say no because ants can't talk. Good. Maybe the 2D plane is different. What do I mean? I'm imagining projection really. I've got a particular projection in mind for sending my world back down. Is that the noise I make at the end of live streams? Could be, couldn't it? Do we get told it's special consideration? I don't know. I went down to questions where the answer is just I don't know. Sorry. Good. Okay. Right. Okay. I think I'm going to call it there. Thanks for joining in with this live stream. I hope it wasn't too traumatic. We're going to be back in 2 weeks' time to do some interview questions. Because, well, interview questions are another opportunity to do some maths during the interview, getting some help along the way. If you're, for example, mixing up red and blue, that the interviewers might notice that you're mixing up red and blue and help you out. And we're going to have a look at some of those questions just because sometimes the maths and interview questions is fun. Should not happen, could not happen, but has happened. And now, like the man itself, is in the past. Thanks for joining in. We will see you in a couple of weeks for another one of these. So 28th of November with some interview questions. Until then, have a nice evening, have a nice weekend. Enjoy the rest of your maths. Take care. Bye.